In this video, we're talking about composite functions, and in this particular problem, we've been asked to find the composite f circle g circle h when f of x is equal to x over x plus 1, g of x is x to the 10th, and h of x is x plus 3. So we have three separate functions that have been defined, f of x, g of x, and h of x, and we want to find the composite f circle g circle h. Well, this composite can really just be written as f of g of h of x. So we have h of x on the inside, then we're taking g of h of x, then we're taking f of g of h of x. So this is the same thing as f circle g circle h, the composite. So what we want to do is work our way from the inside out. So we want to start here with h of x. So in this case, h of x is x plus 3. And we want to plug h of x into g of x. Then we're going to take our result and we're going to plug that into f of x because we're working our way inside out here from h of x to g of x to f of x. Or, of course, if you're looking at the composite notation, we'd be working our way from right to left, from h to g to f. So we're starting with h of x, which is x plus 3, and we need to plug that in to g of x. So here's the way you can think about it. In our g of x function here, we've got x, we're taking g of x, and then we have x inside the g of x function. So when we take g of h of x, what we're doing is we're replacing this x here with h of x. If you look down here at our notation, we have g of h of x instead of g of x, g of h of x. So we're taking this h of x and we're putting it into our g of x function right here. So we're saying g of h of x, and because we're replacing this x with h of x, we want to replace this x with h of x. So that's going to be equal to h of x, and then we're raising that to the 10th power. So we're just replacing x everywhere in our g of x function with h of x instead. But we want to replace it with the right-hand side. So instead of h of x, we'll say x plus 3. So let's just call this g of x plus 3 is going to be equal to x plus 3 to the 10th power. So this x plus 3 to the 10th power is g of h of x. So we've taken h of x, we've plugged it into g of x, and so we've already found this part right here, g of h of x. We've got that. Now we just need to take f of our result. We're going to take that whole result and we're going to plug it into the function f. So our result is x plus 3 to the 10th. We want to plug it into f of x, and of course you could think about it the same way that we did when we plugged h of x into g of x. Here, instead of taking f of x, we're taking f of g of h of x. So we have g of h of x here, and we want to replace x right here, and right here with g of h of x. So you could write it this way. You could say f of g of h of x, like this, is going to be equal to, and then instead of x right here, we want to say g of h of x. And then in the denominator, instead of x right here, same thing, g of h of x like this, and then of course our plus 1. So in other words, within our function f of x, we're just replacing all of the x's with g of h of x. This value right here on the left-hand side is what we're looking for. That's the composite. That's equal to f circle g circle h. But of course, we don't want this funky notation over here on the right-hand side. We want the actual value. So we're going to take x plus 3 to the 10th, since that's g of h of x, and we're going to replace g of h of x with just x plus 3 to the 10th. So what we're going to get is f circle g circle h is going to be equal to x plus 3 to the 10th in the numerator, and then in the denominator, x plus 3 to the 10th plus 1, and this is the composite f circle g circle h, which we found by taking h of x, plugging it into g of x, and then taking that result and plugging it into f of x.